Okay, we want to find the values for x for which this series converges. First of all, we want to notice that this is a geometric series because we have the same exponent here, and this entire thing could be just viewed as being taken to n. So we have x minus 2 over 3 to the n. We have a geometric series, and our first term would be when we plug in n equals 0, because here we're told that that's the first n we plug in is 0. That would give us 1 for this entire thing. So a would equal 1, and our common ratio here is what's being taken to an exponent. So our common ratio, r, is x minus 2 over 3. So now we know something about common ratios. We know a lot about common ratios. We know that if the absolute value of a common ratio is less than 1, then this is going to converge. This is in the case when we have a geometric series. We certainly have a geometric series. We know that because we have r taken to an exponent. So what is r? It's x minus 2 over 3. X minus 2 over 3. How do we solve these inequalities? Because that's what we're trying to solve. We're trying to isolate x, and that's going to tell us what values can we get for x. So we have to solve this inequality. When we have an absolute value inequality, we have x minus 2 over 3, and we would have the negative version of that over here, being less than this. So now we can solve for x. So we multiply both sides by 3, we got negative 3. We've got x minus 2 in there, we've got 3. Add 2 to both sides, we get negative 1, x, and then we get 5. So we have found our interval from negative 1 to 5. So x must be between 1 and 5. That's our interval of convergence. Interval of convergence. How do we find what it actually sums to whenever you have a value from within that interval of convergence for x? How do we know what it sums to? Well, we just have a formula. A over 1 minus r, which would be a over 1 minus r, which would be what we have here. So that would be 1 over 1 minus x minus 2 over 3.